The number of koalas n in a national park can be modelled by the equation n of t is equal to 708 times 2.4 to the power of negative t plus 1, where t is the number of years since January 1, 2004. Now, before we get too far into the questions, what we're going to do is on the CAS calculator in the main screen, we're going to define this function. So our function is 708 multiplied by 2.4 all to the power of negative, and we're going to have x plus 1 for the calculator input. And if we highlight that and go interactive define, we can define that using the ABC keyboard as capital N as the name of x, and now we'll be able to use this in future parts of the question. For part A, we're asked what is the initial population of the koalas? So that's the same as when t equals 0, so we want to evaluate n of 0. So we want to find what n is when x equals 0, so we can drag n of x down and replace x with 0, and hit execute, and it tells us that there's 295 koalas initially. And from the calculator, that is equal to 295 koalas. For part B, we're asked how long is it expected to take for the population to decrease by 80%. State your answer in years correct to 3 decimal places. So, if the population decreases by 80%, that's the same as having 20% of the population remaining. So if we calculate 0.2, which is 20%, times 295, which is the initial population, we find that is equal to 59. Therefore, we want to solve the equation n of t is equal to 59. Next on the CAS calculator, we want to solve n of x is equal to 59. And if we highlight that and go interactive equation inequality solve for x, we find that as a decimal, x is equal to 1.838. So from the CAS calculator, we found that t is equal to 1.838 years. For part C, we're asked during which month is it expected that the number of surviving koalas will be 10 or fewer in the population. So this is requiring us to solve n of t is equal to 10. Next on the CAS calculator, we drag the n of x down and let it equal 10. And we want to highlight that and go interactive equation inequality solve for x, and we find as a decimal x is equal to 3.8658. Therefore t is equal to 3.8658. However, we need this to be in years and months, so the 3 stands for 3 years, and we now need to work out how many months 0.8658 of a year is. And now if we drag the decimal down and we have 0.8658 of a year, if we multiply that by 12, that will tell us the number of months. So it's 10.39 months. So the CAS calculator tells us that it's 10.39 months, which means that the population will be 10 or fewer in November of 2007. For part D, we're asked to sketch the graph of n on the set of axes provided, clearly labelling any axial intercepts with their coordinates and asymptotes with their equations. Where necessary, state coordinates to the nearest whole number. And now just quickly we'll graph this. So hitting the graph icon on the CAS calculator will bring up this screen, and we can drag n of x down. And then we want to reset our window size so it goes from x or t is 0 up to perhaps 10. And then our y minimum we can set to be 0, and our y maximum we can set to be maybe 350. So this is a sketch of n of t. So because of this negative in the power position, we know that it's going to be a decreasing or decaying function, and that's associated with a reflection over the y-axis, or the n-axis in this case. So that means that our graph is going to be in this position here, where the initial population when t is equal to 0 was 295 koalas, and there is a horizontal asymptote in this position here, and it will have an equation that is n is equal to 0. And just so we have another coordinate to put on the graph, we can evaluate n of say 3, hitting execute. This tells us that there are approximately 21 koalas left after 3 years. Therefore, I can put this point on the graph That is, when t is 3, the population in koalas to the whole number is 21. So that is the graph of n of t for this question.